Hey, Mr. Myers here. What we're going to be doing today is talking about inequalities. So what exactly is that? Basically, we have some unknown value, x, and it is not going to be equal to whatever number we have it to. So for example, this x equals 7, that is the one solution that will work. Inequalities let us have a lot of different solutions. So if we had x is greater than 7, this is only going to be true if x is any value that is greater than 7. So let's bring that over here. Let's say we're given a line and we come up with a solution of 7.5. It is greater than 7, so that is a solution in that function. Well, we can also have something that is greater than or equal to whatever said number is. So if we had 7 is greater than, ooh, that's a lot of lines going the same way, greater than or equal to 7, this would still be true because now it is greater than or equal to. That's what this little symbol means. So coming down here, we have greater than, less than, greater than or equal to, or less than or equal to. That needs to be closer, sorry. So those are some of the things we need to think about. We have this equation here, and well, it's not really an equation. Equation implies that it's going to be equal to. We have this inequality here. This inequality is 2x plus 4 is greater than 8 minus 5. How do we solve for this? Well, we're going to do the exact same thing we do as if it were an equation. We're just going to keep this sign. Now, there are some rules that we need to follow with this sign. Well, actually, there's just one big rule, and we'll get to that in just a minute. First, we want to simplify this sign. I'm going to simplify this over here. 8 minus 5 is 3. I'm going to keep my greater than or equal sign. I'm sorry, greater than sign. Plus 4 and 2x. If we simplify things, the sign doesn't change. If we subtract or add across the inequality sign, it doesn't change. So now we have 2x is greater than 3 minus 4 is negative 1. And we now just divide. Here's where it gets interesting. We are dividing by a positive number. So what do you think is going to happen to this sign? Nothing at all. It's going to stay exactly the same. Well, let's say, I'm going to draw this over here. Let's say we have the same thing, but it's going to be 2x plus 4 greater than 8 minus 5. Well, go through the same process. That's going to be 3 plus 4, negative 2x. Subtract the 4 from both sides. Still going to be greater than. That'll be negative 1. Now we are dividing by a negative 2. What's going to happen if we do it by negative? We have to change the sign. Since we divided by a negative number, things have flipped. So we got to change it over there, and we now have a positive 1/2. So what does this mean, actually? In both of these equations, this means that to make this statement true, x needs to be greater than negative 1/2 in this equation over here, and x needs to be greater than less than 1/2 in this equation over here. What happened here? I want you to try and give this a little solve before we move on any further. Well, first off, we're going to follow PEMDAS, so we need to take care of the parentheses first. Over here, I can simplify it, so it'll just be 2 times 3 plus 4 is 7, and that's greater than or equal to, keep your signs. I'm going to distribute the 6, so 6x minus 6. Can't simplify those, so that's just how it has to be. 2 times 7, 14, 6x minus 6. Now we need to add the 6 to both sides, plus 6. So now we have 20 is greater than or equal to 6x. I'm going to divide both sides by 6. It's a positive number. So what happens to this? Stays the same. So x over here greater than equal to, let's see, I can take a 4 out of both. No, I can take a 2 out of both of those. So that goes to be 10 thirds. Yeah. x is greater than, or I'm sorry, 10/3 is greater than or equal to x. Or you can rewrite it if you really want x to be on the left-hand side. X, we're switching sides, so we need to switch the sign, is less than or equal to 10/3. So both of these answers are true. I'm going to draw that line over there. Not well, but I am a completionist.